Here's the solution for the 93 mechanics multiple choice problem number 21. Here's the problem. An object of mass m is moving with a speed v0 to the right on a horizontal frictionless surface as shown above. It explodes into two pieces. Subsequently, one piece of mass of 2/5 m moves with a speed of v0 over 2 to the left. To the left. Okay, the speed of the other piece of the object is, okay, well, first of all, let's take a look at this. I'll draw a quick sketch, which you probably wouldn't have to do if you're actually taking the test, but here it is before. Okay, here's m and here's v0, like this. Now, after the explosion, let's take a look at it after the explosion. You've got a piece that's, was it 2/5 m, so here's a chunk like this. But it's moving like this. So the explosion was so much that 2/5 of it gets pushed with v0 over 2 to the left. Now, what does that tell you about the rest of it? Well, if this is 2/5, this is going to be 3/5 of the mass, right? And it's got to move to the right, and it's going to move pretty fast to the right because momentum has to be conserved here. That's the main idea. So it's going to, well, it's going to be greater than v0, the answer. Can you see why it's going to be greater than v0 if momentum is conserved? If this is moving to the left, this has to be moving to the right even faster than it was before the explosion. So what that means is that you can eliminate A and B. And now if you need to guess, well, you know, if you're running out of time, at least you have something you can guess with a little better. Okay, but let's go ahead and do the problem. This is a conservation of momentum problem. P initial equals P final. And remember, the momentum is a vector, so direction matters. So what is the initial momentum of this system? Well, it's the mass of, it's the mass m times the velocity v0. And we're going to say v, that to the right is positive x. Is equal to, well, here's the final momentum. Well, we got this guy right here. What is its mass? Well, it's given to be 2/5 of m. What is its velocity? It's v0 over 2, but what do you have to do to it? It is in what direction? It's to the left. So you have to put a negative in front of it. And that's probably where most of you made a mistake. If you made a mistake in this problem, is, you know, it's mass times velocity, but velocity is a vector. So you have to think about its direction. And if it's moving to the left, you give it a negative. And then plus, well, the rest of the mass is 3/5 of m, right? And times its velocity. I'll just call it velocity v, and that's our unknown. And so now it's just algebra to figure it out. We're going to add this to the other side. So we have m v0 plus 2/5 m v0 over 2. Oh, I should have simplified this first. Okay. And that's going to be equal to 3/5 m v. And, oh, one of the things I could do is just eliminate m from the equation. All right. And then we've got v0 plus v0 over 5. So that's going to be 5 over 5, get a common denominator, right? So you have 6 v0 over 5 is equal to 3/5 times the velocity of that mass right there. Oh, multiply both sides by 5, divide both sides by 3, and you get the v is equal to 6 divided by 3 is 2 v0, and there, that's why the answer is E. So what's the big idea? And if you're trying to figure out what should I write down for the big idea for the problem, and it really depends on the mistake you make. Obviously, okay, for a big idea, is this. In an explosion, P is conserved. Momentum is conserved. That is, P initial equals P final. Now, one of the things that you could do, let's say the mistake you made was that sign. You might want to highlight it and say, momentum is a vector. Okay, and so you have to account for its direction. Okay? Does this make sense to everybody? And again, you know, for the purposes of instruction, I'm showing all my steps very carefully here. But obviously, you know, I've taken 6 minutes now on this video. You would not, you get about, well, you get a little over a minute per problem. So you'll have to do this a little faster than when I'm doing it. But anyway, any questions? That is all.